once we create a class, we can create objects from it whenever we want because, the class is just a constructor. So creating an object from a class is called class instantiation from the word instance. So you're creating a new instance of this class, a new object from this class, like that. So in the object section, we saw how to create an object literal. Object literal is a singleton. Singleton, I'm sure some of us have seen this word being used in the group at some point. A singleton is just an instance, a single instance. So generally, in the case where we saw singleton being used in the group, it was about functions actually. But anyway, let's leave that for now. I think we'll kind of run into that somehow when we do querying. Object literal is a single thing, meaning it's a single instance of whatever class it's created from. If we want to get a similar object, we have to write it. However, class allows you to create many objects. So this helps to reduce amount of code and repetition of code. For example, you want to create objects for every student in the class. Now, there are basic things that every student should have, like a name, an age, a few other things. I don't know, a few kind of default properties or something, especially if those properties have the same value. So you could just create a class and call this class student, so that instead of going through the motions of creating the same default properties and creating, I don't know, well, exactly the same properties, you just write code, something like that. So define a class. To define a class, we need the keyword class. The class in camel case and block code. So 2 curly brackets. So kind of like this. Person. So today is the class is class. I don't know, I just like that font very well. So we've got class person, and let's look at how to throw in a few things in there. So we've created this person class, but it doesn't have anything inside. Just so we note, it's common. Is like the what do you call that thing now? The general thing, the common thing, right? To create classes starting with capital letters. Just putting that out there. Capital letters for classes. If we do use small letters, let me see if something will go wrong. As you can see, nothing seems to go wrong, but we are writing codes, or we are planning to write code that everybody is going to read, understand, and be okay with. So the general thing is starting with capital letters for classes. Don't use small letters. Or rather, don't start your camel case with a small letter. Start with the capital letter. Okay, so we've created this class, but it doesn't have anything inside. So class instantiation, right? Creating an object from that class. So we use the keyword new, and we call the name of the class after the word new. So to create a dog, they are saying dog object, but they are calling it person. Anyway, to create a random person with our person class, we just say const somebody is equal to new person. So const random dude is equal to new person, and you're going to call this, right? So if we log random dude, yeah, so random dude is just person, like that. We don't have anything in here, so the object, the random dude object starts out with nothing inside. So as you can see, we have created a person object, but the class didn't have any properties yet, so the object is also empty. So let's use the class constructor to pass different properties for the class. Now, the constructor is a built-in function which allows us to create a blueprint for our object. Remember how I said I was talking about, like a person class, and how, or other students, actually, it was students I was talking about. I was saying how students have, some kind of properties that everybody should have. Maybe their values will be different, like name, age, height, things like this. Yeah. So we might want to, having this constructor in our class could help us pass in values for some of these properties. Right? Anyway, let's take a look at how that would work out. So yeah, it allows us to create a blueprint for our objects. The constructor function starts with the keyword constructor, followed by a parenthesis. It's like a kind of default function, so it's always named constructor. Inside the parenthesis, we pass properties of the object as parameters. So we use the this keyword to attach or bind. Bind is the more technical word. To bind the constructor parameters with the class. So inside this constructor, this always means the object. Or rather, sorry, the class. The following person constructor has first name and last name property. So these properties are attached to the person class using this keyword. This is how they're doing theirs. So let's adjust as, instead of calling this person, let's call this, we call this student. Okay, no, let's call this person for now. And later on, we're going to create a student class from the person class. So constructor, and let's just start with 3 things. What are 3 things that everybody has? Can anyone just give me 3 things that every person should have?
Name.
Okay, name.
Age.
And gender. Yeah, everybody has these 3. Even those some people don't want to have that last one. So they did a console log of this. Okay, yeah. This cannot be a property name. It's a reserved word. So let me say, capital this. Yeah, that's nice. All right, so now this dot name is equal to name. This dot age is equal to age, and this dot gender is equal to gender. So essentially, if you want to have certain certain properties inside your object by default, okay, then you'd kind of do some. You'd want to do some binding here to add them to this class. Okay. You could also put some default things like say this dot person type, and that will be equal to, let's say, human. Okay. So now you see, because this was added to the constructor of this class, person type, name, age, gender, all of these immediately got, included in random dude, right? For person type, it was giving a value outrightly. That means every time we create a new object from this person class, the person type property inside it is always going to be human. But it's going to depend on whatever was passed in for, name, age, gender. Yeah. I think we can even be interesting and do this. Panel, the structure, the name of. Okay, so I needed to put this.
Why is this saying that the name is undefined?
Okay, this constructor, I was just trying out something. The parameter I passed in to this constructor at this point is an object, and then I destructured it to get name, age, gender inside. Right, so it means whenever I'm creating an object from this person class, it's expecting an object to be passed into it. Okay, and then from that object, it will now get name, age, gender. Yeah, but since at that point in time, I didn't put an object, that means the parameter passed, the argument passed to it is undefined. But then because of this constructor function, it's going to try to destructure what the argument passed in to get name, age, gender. But then what is passing is undefined. So that's why this makes sense. Cannot destructure property name, cannot destructure this name property from undefined.
Sorry, please, what did you say that line 5 is doing there?
Line 5. Okay, no, this was just a random thing. Just to show us what this is. We are doing this.name, this.age. So I wanted us to see what this is. This is the person class. Okay.
Okay,
let me do this. Const obj is equal to this. Sorry, is equal to an empty object, right? And you can add properties to that obj. Say obj dot. Wait, where is that one coming from? obj dot rice is equal to white. So you see how we did obj.rice is equal to white. In the same way, this is kind of what we are doing here. This is like saying person.name is equal to is equal to this name that is passed in. It's kind of something like that, but it's just that this function is going to run automatically anytime you try to create a new instance. This thing would run. It will just attach all these properties to that your new object. I don't know if that makes sense.
It does not make sense to me.
It doesn't make sense. Okay, what about this one? This obj.rise.
And that one, I understand that one when you want to add a particular
exactly.
property.
Exactly. So the
what
class
I'm asking you now is, let's go to line 6. When you say this dot, line 6, I'm on line 6.
Okay.
This dot name is the same thing as saying person dot name, right?
Okay, let's try that.
And person dot name, the value is name. So when we console log this whole thing, I'm expecting that I'm going to see that place.
Okay, so what you are saying now is class constructor like this one. It's not the same like the way we do that object. Like it does work automatically using the declared name.
So no, say that. Hannah, say what you said again.
Okay, what just did now? This is like a normal way of writing objects when you're writing normal objects. But
is
what
this one you're talking about?
Yes.
Okay.
Okay, what you are saying is this class constructor thing is very different from the way we write normal objects. So you have to clear that number 5 before it can work. That line 5.
No. Number 5 was not necessary at all. It wasn't necessary at all. Okay, so the thing now is that inside this constructor function, yeah.
This line 6, you know that name that you wrote? When you say person dot name is equal to name, that name normally is supposed to be a type of data, which could be a string. But if you notice that thing, that name is not a string, it's just like a variable again.
Yeah, because this constructor is a function.
Because I'm trying to understand. Okay, so if you had put that name to be in double quotes, in quotation, it will not be undefined again.
It's still undefined. The issue here is that
it's still undefined.
Yeah, it's not about it being undefined. It's about the person that is here. See the error, cannot assign to read-only property name.
No, change the person to this. Will it be the same thing?
Okay, let me try something else.
Okay. I'm getting.
There was something similar to this that was done. We did something like this in the object class. I think there's 6 or so. Let me say inside this object, we have something called type. A property called type, and the value is...
Can you scroll up a bit? Sorry.
Have you seen what you want to see?
Yes. The only difference I can see here is that you use class there, you use constant here, which is why this is not really screaming anything.
I use class where?
See, just explain what you're saying, don't worry.
Okay, alright, there's no function keyword. Okay, so look at this. We have an object. Inside the object, there's a property type. and the value is pixels. And again, inside the object, we have this function, what type. So what type is just going to log the value of the type property inside this object, right? Is anything in here strange?
Oh, no.
No. Okay. So let me say, let me leave this and go down. Obj dot what type, and I'm getting undefined. Okay, I didn't tell it to return. Anyway, over here we are seeing the console log pixels. Okay, let me tell it to return. Return this dot type. Okay. So if you look at this, it's kind of similar. Right. Over here we had an object. We had a key value pair inside here. And then we had a function that returns the value of this property inside. But what if you could also ask this function to add something? Say this dot name is equal to hello. Okay, so over here we have object, it just has type and rice and what type. These are the three things inside the object. But let's see what would happen after running what type. You can now see the object now has type property, see, name property, and what type. So if I call inside this object a new property to it. Did you notice that? Hello?
Yes, like I noticed that you added it, like as if you're adding a new property.
Yeah. And we could also change this up to say name. Name. So that means is what we pass in here that would count. So if we said world, then the property name is added with the value world. Okay, so this function is just kind of a represent. Okay, so instead of using this, I used obj. I used object itself, right, to try and add this property, and we still got this. Okay. We have like a final product. Okay, we have an object, a final. Call the object by its name, by its identifier, and add a property to it. Class. Person is a class, not really an object. So it's trying to add, or add actually. It's trying to add properties to the object you're doing. But then you don't know what the name of that object you are going to create is. You don't know its identifier. I don't know what you are going to call it. So you don't have a particular name to put here and say that thing dot whatever property you want. Because this would always be that object that is being created. Does this make sense? Nobody's saying anything.
I think we are with you.
Are you sure it's me? Because if you're with me, you'd have answered before now.
We are processing it.
Okay, because this is kind of like a response to somebody asking why we're using this. And I showed you. But this one is like a factory, an object factory, object producer. This is the final product, an object. So in an object, you can have a function like this that can add properties to this object. And in here, you can either use this dot whatever property to add a property itself dot the property to add the property, to add whatever value you want to add, right? And that's because this is an object, you know its name, so you have two options, right? You can either say this, because this would mean the object, or you can call the object by its name. But over here in this class, this constructor is basically doing what this function is doing, kind of. You are trying to use it to add properties to the whatever objects you are going to create from this class. So, because this is a class and not an object, it means one of those possible ways you could use to add properties to the object has gone. Because this is now the factory, not the final thing. So you don't have an identifier for the object itself that this constructor is going to work in. So you can only use this. Because this would always mean whatever object it is that you are creating. So inside this object, add this property with this value. That's why we use this. And that's why if you use person, it will not work. This function, call the class and start making changes. The properties of this class are just read only inside this constructor. You can just read them. You can't, because this constructor is going to run inside the child, inside the object. It can't be making changes to the class itself. The class is the factory. Anyway, so for this, we can see if you add a name, random dude, Mitchell, and his age is, and new. Yeah, there you have it. This is random dude. Okay, any questions so far? They say silence is constant. So what are your questions?
Is it possible that you can put all those, go back to that thing again, the Visual Studio
I
Code?
think to mute his mic, I beg.
King. Try to find, and I don't.
Can you mute Akim for us?
Unfortunately, I can't.
Josephine, go on with your question now.
So I was just saying that instead of you putting those the various arguments into that new person, isn't it possible for you to write this dot name is equal to Michael, this dot age 35, this does gender me in this place.
In here?
It's not possible.
Oh, that's why I did. What this means now is that if I do this, let's say random do this, and this will be Michaela, and this will be 30, and she will be female. Okay, and here we have Michaela, 35, 30, male, female, but person type is human in both cases. And that's because this was made human here. So any object that is created from this person class is going to have person type as human. If I did put Michael and 35 and male here, it means that even random do this is also going to be Michael with age 30 and she'll be male. Okay. Let's try that.
I think
You think what?
I think the reason why we can't do it straight away like that is because it's supposed to be a class. Like it's not like it's supposed to be like a blueprint, so we can
Exactly, it's a blueprint. So
manipulate it however we want.
So with this, you can make some little changes. You can be able to accept values every time you're creating an object, so that different properties would have different values. Okay. So hard coding the name as Michael here means it doesn't matter what you do. This person, whatever object you create, their name is going to be Michael. Even though we passed in Michaela here, it doesn't matter. Her name is still Michael. So that's why we use the name from the constructor. We use the values from the constructor to do our thing here. I only had coded human because we are going on the assumption that every person is a human. You get some properties. Weird. Somebody. Yes. What do you have to say? Yeah. What would you like to say?
Okay. Yeah, bro. I wanted to say, can we like for example now that random dude now can I had like if I had two different arguments that are not in the constructor, like is that going to
Extra
work?
arguments.
Or it will give like an undefined shit or something?
Extra arguments.
Like maybe like and a married argument, so that is false or something. I don't know how do I explain that?
And what like extra arguments here now?
Like besides the corresponding parameters in the constructor.
You mean line 13?
Okay, like instead of male, I put false.
You put false, then maybe for like which other?
It's just going to attach them to whatever.
But there won't be like a property when.
No. See, all that matters here, when you're accepting parameters in a function like this, you are looking at their order. So basically, the first thing you put in is name. It doesn't matter if I write, I don't know, an array here. This array has become the name, and Michael has become the age, and this one has become the gender. It's just looking at order. You get?
What he was asking you is, we know you are following order. Go back, follow your order. But add one extra parameter that you did not define in your class.
I think he already did that.
What happened?
You see now, we have 5 parameters here. It's only going to take the first 3 because this one is only looking at 3 things. 1, 2, 3. The first thing becomes name. The next thing becomes age. The next thing becomes any other thing you're adding. You are just wasting your time. It won't show up anywhere. The constructor.
Sorry, can I have a
It's like having a function. Yeah.
So like you're saying like constructor works just like a normal JavaScript function. If you have access parameters, you can just keep them.
Yeah, just like this. If I added extra, this one takes only name. If I said what type word and I say hello here, the hello is a waste of my time. It's not going to do anything because this function only uses the first parameter. So any other thing you add in is a waste of time.
Thank you.
Yeah. Weird dude, are you okay? Mr. Weird. If you like, don't change the name.
Yeah, I'm okay, bro.
Okay, so I think we've also experienced this undefined and undefined. At the beginning, when we didn't add arguments to random dudes, the properties. Okay, so yeah, you add stuff inside, and then the constructor works and adds values to those properties inside the new object. So as we stated from the very beginning, once we create a class, we can create many objects using that class, and we do that. So let's create many objects using the class, and we kind of did this, so we move on. So we created three persons objects, person objects, I think person objects. As you can see, our class do not have many properties. They missed they have here. Let us add more properties to the class. So I don't know. Do we add a bunch of other things? We already have three things in there. I don't think it's so necessary. So yeah, default values with constructor. So the constructor function properties may have default values like other regular functions. Okay, that we didn't do. So let's try the default values. As you can see here, something like if a first name is not passed, use this. If the last name is not passed, use this. That kind of thing. So let's go take a look at that. So again, it's just like regular functions. You know, you can do this with regular functions. So if no name is added, I don't know, call them John Doe. If no gender is added, sorry, if no age is added, 18. And if no gender, what do we call them? Non-binary. Okay, so if we didn't, let's say for Michael now, we didn't put an age for him. Okay. This thing normally works in arrays. How do we put, let's say an underscore. So we have name, gender is false. Let me make this something male. Okay, it turned age into this. Okay. So how about I make it 35 and leave out the other one, so gender becomes non-binary. So this is troublesome. How do you not put a middle value? I don't think null would work. If I wrote null, it will just give it null. How about undefined? Okay. So if the value is non-existent or undefined, then so there we have it. Okay, so that means if we tried creating a new person without passing anything inside, they would be John Doe, they would be 18, and they would be non-binary. So, class methods. So, the constructor inside a class is a built-in function that allows us to create a blueprint for the object. In a class, we can create class methods. Methods are JavaScript inside the class. So let's create some class methods. So here one was created. Get full name. It just adds the first name to the last name with a space in between and return that. I think to really enjoy this, maybe we should split name. Or do we add address? Oh no, let's do something else. Let's call it introduction. So let's say context is equal. Okay, so I want to do this now. I want this thing to say I am name and I am this years old. So can someone help with that? We're just going to have that in text and then return text. And that will be introduction. So what do we do?
Okay. If you use template literals.
Okay, you're a fan of template literals. So what do I write?
Okay, so you're going to do I am, then space,
Then what?
then to be then the dollar sign, then the curly braces.
Okay. And what will be in the curly braces? What will be in the curly braces?
This dot name.
Okay, this dot name. Alright.
Yeah. And then comma, I am that year
I think comma is good. And I am another of this dot age is old. Okay, so let's duplicate these two. So we have random. Oh, we forgot something. We're getting undefined. Can you correct that?
We are not
Return it.
Okay.
but I will not
So return text. We're getting I'm Michael, I'm 18 years old, I'm Michaela, I'm 30 years old. So all good on this, Obi?
I'm not seeing the thing that you are returning. I'm not seeing the outcome. This is my screen that is freezing. Okay.
I think this is
It's
network.
network.
I'm seeing it now.
Okay. Okay, that's good. So no questions on this, Obi? Yes, no questions. All right, properties with initial value. So when we create a class for some properties, when we create a class for some properties, we may have an initial value. For instance, if you're playing a game, your starting score will be 0. So we may have a starting score or score which is 0. In another way, we may have an initial skill, and we will acquire some skill after some time. Okay. So in this case, we're not going to have score. We're going to have, I don't know, account balance. So everybody's account balance is going to be 0 at the beginning. But we say this dot money. I think that sounds shorter. And then for skills, we'll still leave it as skills. Still leave it as skills. So let's try adding those two properties and see what's up. So again, just like we had person type, this dot money is going to be 0 for everybody, and this dot skills is going to be an empty array because you're born without skills. Okay, so we have 0 and empty array for both parties. And what can we do with that? So that means we could have a function to add money to somebody or something, get paid at the end of the month. All right, so two other things we'll be looking at are getters and setters. So let's start with getters. So the get method allows us to access value from the object. We write a get method using the keyword get followed by a function. Instead of accessing properties directly from the object, we use getter to get the value. So let's see the example below. Get score, return the score. So you might be wondering, why bother going through? I mean, we could just say get score and return this dot score. Why do we have to why do we have to add this? What benefit is there? Well, let's go see that benefit. So what do you think we should call this function, this getter, to get money, like the person's current money? What do you feel is an appropriate name for this function?
Get balance.
Get balance, okay. So when you're creating getters, it's the order of the day to start the function name with get, because it kind of makes sense. In some cases, you may choose to avoid that. After doing this, we'll look at one of those cases. Well, it's not like we're going to do it. We're just going to think about it and see that actually does make sense. Return this dot money. So now the interesting thing is the way it is used. Random dude dot get balance. So it's used as a property, not as a method. That's the nice thing about getters. So can you think of any method you know that behaves kind of like this? Use it to get a property of that thing, whatever you are running the method on, and you don't add brackets to it. It's not a method. It behaves like a property. Anything like that you know? Anything?
Dot length.
Exactly, dot length. Dot length is a getter. So it's used like a property. So it kind of makes sense, but it doesn't start with get. I mean, array.getLength. I guess that would still work well. It's still nice being just length. But anyway, I guess it's all up to everybody's tastes. But yeah, we've seen how getters are. So of course, we could also do some manipulations to this money before returning it. Say, I don't know, add a naira in front. Where do I get naira from? Yeah, like this. So all good, sure. So that's getter. Yeah, also get skills. This one returns the array of skills. Okay, so now setters. Setters allow us to modify the value of certain properties.
Wait
So we
first.
write a setter. Yeah.
If you don't put that get, does it mean that the thing will not work? I don't understand. If you don't put the get,
Okay.
will you not
If
still
we
bring that?
don't
I think you have to call it as a function if you do not put it there.
exactly without the get, this shows this symbol, which means it's a function, and we've not called it. So you do this, and you get this. So it's up to you, Sha. If you want to be calling a function to get this value, fine, leave it as a function. If you want to access that thing like a property, then you make it a getter. And then just use that function without calling it like a proxy. So anyhow you want to go about it.
Okay, I've seen the difference now.
Yeah.
But that place that you wait, go back to
Yeah.
that place that you wrote get.
Okay.
Okay, you still
It,
wrote it as a
it's
function.
yeah, it's still looking like a function. The only difference is that there's
What you
get in
want to
front of it.
call it is the difference.
Yeah.
Okay, I understand.
All right. Okay, so setters allow us to modify the values of certain properties. So similarly to the get, you just write set in front of it followed by a function. So I guess the main difference between setters and getters would be that you are usually passing something in for setters because you're trying to change the value in some way, the value of something in some way. So you pass in a value. Unfortunately, okay. So once again, um, it kind of works weirdly. You say set score is equal to something, and it just runs like that. So let's try that. So set, again, we'll be working with balance. So do we say change balance? Why is this one telling me funny things? I've not even written anything, it's already complaining. So we're going to add a number. Yeah, this the money is a number. So let's make it number. And we're just going to what are we going to do? We're going to add this number to the existing money. Yeah. So this the money plus equals number. We'll call this amount instead. Amount is nicer to the ears. Amount. Again, why is this thing? Change balance because it's set accessor lacks a parameter type annotation. So if I wrote set here, would you complain? Still complain. Is this not JavaScript? Why am I seeing TS? Oh well, such is life. So again, using this setter will be interesting. It doesn't really have a return value, so I'll try to write it random dudes dot set balance. You can see it's a property, funny enough, is equal to, I don't know, 700, 7,000, like that. And if we Drag this down, we get 7,000. So let's duplicate this for skills, and there's something I'd like to try. Because I'm sure you'd have a question too. Do you have any question at this point? Like, this was fun because we're only adding one thing. Like, we're just putting in one thing. What if we wanted to put skills, multiple skills? What would happen at that point?
I have a question.
Yes, what?
It's a balance. I will not put amount. Okay,
Sorry,
I'm
say
trying
that
to
again.
the set balance.
Yeah.
We now they will put this money plus is equal to amount, right?
Yeah.
We will not return anything. No.
They return anything. It's not, setters are not built to return anything.
Okay, so
They're
that's
just
first.
built to do their job and go away.
Okay, then this money is equals to this money. Was it zero before? Was the initial value zero?
Yeah, the initial value is 0.
Okay, so
We have not changed it since the person.
so you now say plus amount. So the amount, where did we get the amount from?
Is here. Whatever value you give, use it and run this function.
Okay.
And do whatever it's supposed to do.
Okay, so like you were saying, if you have more than one value to add.
Yeah, I'm curious about that too. Anyway, so this first, how would you add that to this dot skills? Does it mean yeah?
This dot skill dot push. Yeah.
Okay, this dot skills dot push and skill. Okay, and that is nice. So if I said, okay, let me just create a getter for skills. Get skills. Return. Okay, so now skills is an array of things. I don't want it to return an array. Can you just write something simple to make it return a string separated by commas?
I think it's in a dot split.
Dot split. Are you guys going with dot split?
No, dot join.
Dot join. You now put that. I put comma inside. Put double quotation.
Sorry, dot split does not change an array to normal distance.
We want to convert an array to a string, not a string to an array.
Split is usually used for strings to turn them to an array. You split a string into an array. You join an array into a string. So is it just the comma?
Yeah, comma. Just comma is fine, Abby.
Just comma is fine. Okay, let's find out.
Okay.
Okay, so random dudes dot set the set skills is equal to what are we adding? Programming.
Oh.
GitHub. Okay, let's go with that. GitHub. Okay, and if we log random dude dot get skills, we get GitHub. Okay, let's add another one. What will be the next skill?
HTML.
So, are you sure just the comma is fine?
I guess you can put it.
You put
Yes.
a
Space,
space.
space after the listing.
Okay. Space after the comma. All right, that's fine. So yeah, again, now we're back to this. What if we wanted set skills to be a list? What? I think it's still fine like this. That means if you want to add multiple things, you just have to run set skills multiple times.
Yeah. Is it possible that we do uh is it possible that we split it, then we map to it, then we fix it?
Split it, map through it, and then what?
Then we do this dot C dot push of those individual items.
Not really. Even if there was going to be something like that, I think it would be this. You'd say array of skills, and then you push split that array of, sorry, it's not split, spread that array of skills. So let's say this one will be called set multiple skills. Okay, so if we called set multiple, CSS, right, set multiple skills. Okay, this is JS. It's looking only at the first item. Or am I mistaken?
Could it be from this from the parameter?
Sorry? It's the way your voice is muffled. It's kind of hard to make out what you're saying. Are you trying to say it again?
Okay. Can you hear me clearly now?
Yeah, very clearly.
Okay, so on that line 36 now, can we like have okay, no. So that parameter that we're passing into that part, can it just be a normal variable? Then in here we can just do we can just spread the this.skills and then comma with skill itself. Oh, am I making sense?
I think you'll have to say it again.
Okay, so like can you hit enter there now? So here now
Okay.
I'm thinking we can now have like the array brackets. Then we can now have this.skills, then comma, then skills. Yeah, I don't know. I
And
don't
then
know if
assign this to this.skills.
Yeah, maybe. Yes.
Okay. I think we may have to split this too. So I'll comment this out.
It didn't work.
I'm still getting
Okay,
the same.
Can you change? Can you move the array bracket on the skills parameter? Yeah.
Oh, that's the issue. You're right. That's the issue. It's looking at the first this thing. It was going to work the other way too. That's
Yeah.
true.
So let's just change it the other way.
Yeah. So this would have also worked. Let's see if I comment this. That's true. So anybody gets why it wasn't working before? It's a very funny issue.
Aha.
Yeah, that's true. It was because of the array. Do you guys get why it wasn't working before?
Wow.
Let's see. What this means is that this function is going to receive an array, then it will destructure that array and pick the first item inside, and that first item is now called array.
But this is really funny though. I don't know.
Yeah. It was just a mistake that slipped me.
Oh, God.
Second will be
And
2,
then
and third will be 3.
God.
So there's this very interesting question. How was it there? I know there are some trick questions that are built around this. Anyway, that aside, I think we've seen how multiple skills works. So I guess we could even do something here that would check if it's an array.
Oh. Oh yeah.
So how do we do that? Let's check if it's an array. We do this.
We do this part, and else we just do that.
And if it's a string, we do this. But if it's not any of those two, we don't do anything. So how do you guys think we can adjust this?
I guess if is array, we can use is array, right?
Is that how it goes? Okay.
I have to check for an array.
Any help from anybody? Because it's not array. Array is not defined.
I think array dot is array or something.
Felix, I'm surprised to see you here.
What?
Oh yeah. Sure.
By the way, thanks for your help. So if array dot is array, what?
Skill. We're passing in the skill there.
Okay. Then what should happen?
Then we should do this dot skill dot push. Yeah.
Okay. So how do you check if it's
to check if it's a string.
If type of skill is equal strictly
belly on fire. So if type of skill is equal to what?
Skill. String rather.
string. Okay, then we do this. All right, so what else are we adding?
That I should not do anything if it's not any of those two.
Okay. So I guess we can even leave it like this.
Yeah.
Yeah. So that means this guy is going to go away.
And then we can now use that same setter.
Small problem. Remove. Yes. So over here, set skills. Yeah.
Yeah, it works.
You add one, add more. So let's try something else. Let's make this false. And nothing is added. If we make this an empty object, it's false is equal to true. Nothing is added still. All right, so our set skills function is working awesomely. Okay, so we're done with getters and setters, right? Then you can do some manipulations inside your setters and your getters. And, you know, the way you use setters. This one is the weird one, really. The fact that you're setting something and you're saying it's equal to something. It's just funny. Okay, so do not be puzzled by the difference between regular methods and getters and setters. If you know how to make a regular method, you're good. So let's add regular methods called getPersonInfo. That's so necessary. I don't think we really need to get into. We've already done something like this.
Yeah.
Yeah. Okay, so yeah, all of this getPersonInfo. Nice. So now static methods. So the static keyword defines a class. Static methods are not called on instances of the class. Instead, they are called on the class itself. These are often utility functions, such as functions to create or clone objects. The best example of a static method is date.now. It's called on the date class itself. The now method is called directly from the class. So, static goes at the end. Favorite skill. So let's look over here. We had the constructor that does all of this and all of this. And okay. So okay. So now in this static favorite skill, there are just a bunch of skills in there. And
I guess
select one and return it. Yeah. There's also static show date time. This is just funny. Okay, let me see. We're getting all of these. Okay, yeah. Date month. I want to add something else instead. Object, or rather person class. Just like there are static methods, if I remember correctly, I think there are also static properties. So I want to create a property that will keep a count. Every time set skills is used, I think. Zero. So every time set skills is used, let's set skills. Set skills used. Ooh.
Don't we have to use like this on it?
Yeah, come on. Yeah. Person that set skills used plus equals 1.
Oh.
So now a static get what's up? Get sets. That's funny. Get set skills used. Return person dot set skills used. So I guess you can see the difference between static properties and, do I call this dynamic properties or what now? Anyway, like over
Methods.
here, for example. No, I'm even talking of these ones. Over here,
This
for
one for
example,
this data, okay?
we couldn't do person.name because
Yeah.
name doesn't belong to person. Name belongs to whatever object is created from person. But set skills used belongs to person. It doesn't belong to the objects created from person. It belongs to person. So we can say person.set skills used. So I'm just trying to draw that distinction between the objects created from a class and the class itself. So I think after doing all this, let's see if what we did is going to work. Person dot get set skills used 4 times. So it was called 1, 2, 3, 4 times. All right. So we have this. I think we could also add one self static number of persons created. And we have this at 0. So one thing that we are sure of is that every time you instantiate this class like this, you create a new object. This constructor
We call the
function,
constructor.
yeah, is going to run. So you can do that. You can say person number of persons created plus equals 1.
Plus equals 1.
Yeah. And then have a static method once again that would get persons created. But it feels like we can. So if we see the number of persons created 2. So I think we've fairly experimented enough with static methods and static properties. So again, it's one of those things. It's customary to add this underscore in front of, or is that? I think that's for private listening. This is one of those things I said we're going to look for outside. I don't think was in here. So let's go look for that. So this is 4:33. We have about 30 more minutes. I think that 2 hours is not enough.
No, no, that's found that static distance.
Akim, you need to mute. Akim. Okay, so Josephine, you can carry on.
Okay, that static. What's the difference? I'm trying to understand the difference.
Okay, the difference between static is that static, once you add static, it means it belongs to the class. Okay, this property was created, right? Set skills used. If we come to over here when we created random dude and look at the things inside random dude, you notice there is no set skills used or number of persons created.
Yes.
Yeah, because that property, it doesn't belong to the object that was created from this class. It belongs to the class itself. Also, these two methods, get skills used and get number of persons created, these, once you put static in front of it, it no longer is given to the object that is created from that class. It belongs to the class itself. The class doesn't give it out. So we can't say random dudes dot get number of persons created. It doesn't exist on it. We tried that. Undefined. You know, you get undefined when you try to access a property of something, of an object, but the property doesn't exist.
I think one thing to also point out is every property that actually belongs to this random dude are inside of the constructor, and actually this static property is not inside of the constructor. So
yeah, I pointed that out. If you look over here, okay, here, you see those stuff aren't here. So that's the beauty of static, or that's what the different thing you get when you use static.
So are you saying that you use static func methods to add a property that is not in the
Yes, you use the static keyword to add properties and methods to the class itself.
Okay.
Yeah, but for use the constructor
originally. But if you log,
it's not like it wasn't there originally.
I'm trying to understand it.
Okay. Person is a class, is a factory for making objects, right? It's a blueprint for making objects.
Okay.
But whatever function, whatever properties that show up in this constructor will be given to any objects created from this person class. Just like that. Just for them existing, they're going to have those properties.
Okay.
Mm-hmm. Any methods you write in here under this constructor, after this constructor, even before the constructor says, but it's good to write the constructor first. Stuff you write like this, they're going to be given to that object. So you can say random dude.introduction, right? These getters, the setters, they will all belong to any objects created from this class.
Yes.
But now there may be some reason for you to have properties and methods that exist only for the class and not for the objects created from it.
Okay.
And that is where you use static. So anything that has static in front of it will not be given to the objects created from that class. They would only belong to the class itself.
Okay, I think I understand now. Okay. So, you know that all these things that we're learning now.
You are looking for where you can use it.
Because it's so abstract.
That's why I tried to use this particular example, right?
Okay.
So in this case now, I created like a counter to keep track of how many times, how many objects are created from this person class. That's what this is for. Number of persons created, because every time you run new person, it's like you're creating a new person object.
Okay.
And that's what this is for. So every time you create a new
Object.
person,
Yes.
yeah, it will just add one to this counter and just be there. So at every point in time in your code, you can just come and run get number of persons created and see that, okay, this object has been called 4 times. Sorry, this new objects, 4 new objects have been created from this class. 5, 6, like that.
Move up. Where did you put it?
Inside the constructor.
Okay, everything should be inside the constructor.
Not necessarily. See, first of all, you get why this one is here, right? Number of persons created. This is just like a counter variable. Count.
Yes.
It starts at 0. This one, no issues there.
Yes.
The reason why I put this line inside the constructor is that every time you create a new object from a class, this constructor function is going to run. Just by you creating the object, just by you saying new person, so is equal to new person, this function will run. So it's the best place to use and say, to keep track of when a new object is being created from the class.
Okay.
That okay is sounding weak.
I'm processing.
I'm processing. You don't sound. Okay. I will continue if the processing fails. Let me know.
Continue. Don't worry. I will still go through it again. Shall you turn this thing now?
I hope so. I hope so. Don't worry, I'll try and put it on this thing and send it. Carbon.now. I'll send it as a picture. You've seen those code pictures now, to be fun. Okay, private properties are counterparts of the regular class properties, which are public. Let's increase this. Okay. Private is different from static. It's what I'm seeing here. So private properties, I feel like we should just start from here and just see what they have. Okay, so classes are a template for creating objects. They encapsulate data with codes to work on the data. Basically what they're saying is, this is the data and this is the code to work on the data. So yeah, so classes in JS are built on prototypes, but also have some syntax and semantics that are unique to classes. Let's go see what prototypes are, because this is an interesting, it's something you can't skip when it comes to classes. So in programming, inheritance refers to passing down characteristics from a parent to a child, so that a new piece of code can reuse and build upon the features of an existing one. So JavaScript implements inheritance by using objects. Each object has an internal link to another object called its prototype. That prototype object has a prototype of its own, and so on, until an object is reached with null as its prototype. By definition, null has no prototype and acts as the final link in this prototype chain. It is possible to mutate any member of the prototype chain or even swap out the prototype at runtime. So concepts like static dispatching do not exist in JavaScript. So what they're saying is, yeah, that's true. Have you ever console logged an object in the browser before? Let's try it. I think it will help with this. So currently in this index.html, we're linking day 14. Was there any objects? Okay, let's console log an object of our own. Ooh. Okay, and we're going to go live. I was in. Okay, I wasn't in there. Okay, so intermediate. Yeah, so this is our object key value. Now, if you notice, every time you log an object to the console, you would always see this prototype. So when they say every object has a prototype, it's like every object is kind of defined by another object. So it keeps that information about that object is kind of created on or modeled upon. It keeps like a detail of that object it calls its prototype. So you would always see that here. And I think it's this. This is the way to get here. So this is what they mean. This is the original object, right? Key value. This is its prototype. Inside its prototype, you can get the prototype of its prototype by doing this, by coming to this underscore underscore proto underscore underscore. Inside that prototype, it still has a prototype of its own, and that one is null. So they are saying that for every object, it has a prototype. That its prototype has a prototype. You know, inside your API, another API on the inside. Like that, you keep going until you get to null. That's what.
Indeed.
You can't see what?
I can't see your screen. I think you expected something.
Are you serious?
How the
Okay. What about now?
was just what you expected.
Sorry, I didn't hear you. You can see it now. Okay,
I
so
see.
okay. So this is the original object that I console logged, right? This one just has key and value. And if you notice, in every object that you open, you would always see this prototype. So if you open that prototype, you would see some details about its prototype. So now, inside that its prototype, if you come down here, you see this proto. You can open this, and you see the prototype of its prototype. You can see constructor has own property, all of this. It's just like what was here. So if you come down again to this proto property, you see that it's null. So I'm just talking about this line that was here, right?
So are you saying that prototype is like a copy of it?
It's like the blueprint sort of what was used to create this object. Where did this object get? Because you create an object and the object has some default methods and just by existing. You notice that you create an object and you can do object.has own property. You can do, there are some methods you can run on the object.
Yes.
So those come from its prototype, the blueprint that was used to create it. So they are saying every object has a prototype. And the prototype of that object has a prototype, has its own prototype. So it just keeps going like that until finally you get to null. So we just saw that the object we created that has just key and value had a prototype. That prototype had a prototype. It's the prototype of that second parent prototype that was now null. So essentially they're saying you can keep going, but finally you will always get to null. So by definition, null has no prototype and acts as the final link in this prototype chain. So it's possible to mutate any member of the prototype chain or even swap out the prototype at runtime. Yeah, so basically you can change the prototype of any object. Over here we have this. Let's say this is console log new obj dot underscore underscore proto underscore underscore. Yeah. So let's duplicate this. And over here we're going to say new obj dot underscore underscore proto underscore underscore is equal to, I don't know, a random object that has hello and world. Okay, so essentially what I'm doing is this is a new object, right, that we created. So we just look at it and then we log its prototype and then try and see if we can change its prototype to something else, because prototypes are just objects. And then log its prototype again. So let's see how far this goes, or how well this will go. So this is the object that was logged. We logged this prototype, then we changed this prototype, and we logged the prototype again. You can remember that, right?
Yes.
Yeah. So that's what they mean about any object's prototype can be swapped, can be changed at runtime, as in after it has been created, right here in the codes, we just change the prototype to something else. Well. So JavaScript is a bit confusing for developers experienced in class-based languages like Java or C++, as it's dynamic and doesn't have static types. So while this confusion is often considered to be one of JavaScript's weaknesses, its prototypal inheritance model itself is in fact more powerful than the classic model. I personally don't know this classic model. I've not done Java or C++, so I don't have anything to like compare this prototype inheritance model with. Okay, so although classes are now widely adopted and have become a new paradigm in JavaScript, classes do not bring a new inheritance pattern. So understanding how prototypes work is just based on objects, not really classes. Well, and it's still helpful to know. Okay, so okay, so apparently we could also do this. Instead of underscore underscore prototype, proto underscore underscore. We could also do, let's try and see if this will work too. Didn't. Doesn't seem to recognize this. Okay. Okay, so this is equivalent to the JavaScript accessor proto. Okay, so I don't think you can type this in VS Code and get it to work, but you can use this. They are both kind of the same thing. Just over here in MDN, they are going to be using this instead of proto, but they mean the same thing. So you can get, instead of doing this, you can also use object.getPrototypeOf, and you can use object.setPrototypeOf to set the prototype as well. Of course, the way we did it also works. So there's that.
So, okay.
Yeah.
Because I'm trying to see how to make the thing stick without making it abstract. Let me say, for instance, we have a database where everybody like is in this class now. Me, I have my own name, my age, my gender, and goodness also has. So instead of me creating separate object, like if I want to create an object that will contain an object that maybe an array of objects, I can have I can create a class, since all the classes, they have the same properties. It's just the people that are the person 1, person 2. So in that array, person 1 can be object, we represent, after I've created the class, person 1 can now represent Josephine. I don't know, I'm trying to see how they use this thing so that it will stick.
Okay, I get.
Because from all the things that I've talked about, classes is all about, you don't want to repeat yourself. So
It's about creating a template to use and generate.
Yes. That's what I just got. But I'm just thinking of how they will manipulate it. I don't know. Just thinking.
Okay, before we close, let's just do this one last thing. Let's talk about extents. Constructor name. This is the name is equal to name. What other properties should the coders then member have? Affiliation. Let's call it affiliation.
Stack.
Stack. Stack will be different for everybody.
Okay.
Yeah, stack is good.
I want to use skill.
Okay, sorry. This is the affiliation would be coders then. Okay, so you said stack. Let's give a default value for stack. Name, what should be a default value for name?
If you put a default value for name, you cannot change it again.
No, you should be able to change it. Let's see.
Okay, that's only when they don't give. Okay, I understand.
You just raised the variable. Listen, let me try it. So here, random dude has the name Michael. Okay. Yeah, this was the default value, 18. We didn't give him an actual listing. He used the default 18.
And it's only when if they did not give, is the
So
default.
Let's see if we can set the name. Random dude.age is equal to 35. So now if we check over here, it has changed. It's now 35. So name can still be changed later on. So yeah, John Doe, stack. So intermediates, let's say this dot class level or this dot level. Okay, so we have this class, coders then member, right? Any objects created with this are going to have these properties. It's going to have a name, affiliation is going to be coders then. Okay. So now we can create another class called intermediates that extends coders then member. So if you create some objects with this intermediate class, it's going to give them the necessary what do we call it, sir? Let me see how to describe it here. Okay, so using inheritance, we can access all the properties and methods of the parent class. It reduces repetition of code. So you remember we had a person parent class. We can create children from it. Our children class could be students, teachers, whatever. So the syntax is just like we did. Class, the new class name extends the bigger one. Yeah. So creating students from person and passing all those variables, yeah, it's just going to still going to do all of that. Yeah, then overriding methods. This was the thing I was looking for. Super. So when you run super with the variables that are passed in, this super is going to run the constructor of the bigger class. Like this new class is extending this bigger class. So running super is going to first of all run the constructor of this bigger class, and then later on you can make some adjustments. So that's just what I wanted to see from here. Name, stack, and then we add level. So here we can confidently accept name and stack. What I'm saying is that if we try to create any object with intermediates, this super name stack is going to run this constructor. So to give them the name and the stack. Let's try an example to help us understand. Mm, so we pass in and what's your stack?
Front end.
Front end. Yeah, I'll just put these three then. Okay, so name, Jamasi, affiliation, coders, then level, intermediate. Okay, sorry, I didn't use this stack. This dot stack is equal to stack. So we have stack. Let me comment this out. Yeah. So must call super constructor in derived class before accessing this. So as long as you want to make your own changes, yeah, it seems once you're extending, you just have to call super. Let me see, if I remove this constructor, that still doesn't go away. And if I remove this constructor as well, it goes away. So as long as this new one has a constructor, you must call super, or things will just go wrong. And super can be called without these, just in case you're worried. Yeah. You can just call super without passing anything inside. So in this case, it will just give default values for the earlier things. No wahala. For now, any issues with this extent?
No, but I think I should just, like you said, you will upload this page on so that we can access it. I just want to go through this thing again.
Sorry, can we like get the link to the repo, to the Dark 30 Days repo?
You don't really need a link to it. You just need to search on Google. It's very popular.
Oh, okay. Thank you.
Yeah. Okay. Let me. Let's try something, see how it will turn out. Oh, crap. I think this is all right. Okay, so tomorrow we'll look more into, this inheritance and prototyping. For now, we've basically done most of what we're supposed to do in classes. we add extending, after this extending, there's overriding methods. Okay, and that's even really the end here. So I'll try and look for more use cases in classes. Maybe one or two things, like example kind of thing that we can try and do to help us get a better handle on classes. And that will be that. So thank you all. If there are no questions, that will be the end for today.
Thank you.
Welcome.
Thank you.
Yeah.
Thank you so much.